you. So we are now handing this over to you. Here, before we do that, let me change the video here so you can see us. There we go. There's people. Say hi, people.
I'm waiting to see you.
Someone's getting food. There's James. Hi, James.
Yeah, I don't see your video.
All right, that's probably. I'll probably kill the connection. It's over my cell phone. I've got like Bubkus wireless stuff. All right, let me try that again. It doesn't. All right, who cares? Anyways, we can see you. We can see your presentation.
You guys can make all kinds of faces at me, and I can't even see them.
I can. I will do them in ASCII art in the comments window.
Yeah, let me pop that open too. Just in case.
So everybody here, since Sean is remote, he cannot hear you as well as he can hear me because I'm right in front of my laptop. So if you have a question, I will rudely interrupt him and ask him your question. I will repeat it back to him and share it with you. So, and Sean, would you like to do questions while we're doing this, or would you like to wait until afterwards?
No, that's fine. If there's something in stream, that's fine. Go ahead and grip my attention. But if it's something that can wait till the end, it might be a little easier to handle it there. So it's really up to you, however you want to handle it. Okay. All right. So if anybody starts waving their hands like they have to go to the bathroom really bad, we'll choose them then. Otherwise, we'll wait till the end. And with that, we will give the screen over to you. So thank you for joining us from your Cincinnati digs and for presenting with us tonight, Sean. My pleasure. Okay, right. Folks. Well, this summarizes Microsoft Technologies really well. Now, I want to start by saying I love Microsoft Technologies, but I wrote something on my whiteboard behind me here, and it says, I've got a big hug for BASPUG. The only problem is, for some reason, when Link or Skype is looking at me and taking my video, it's inverting it. Is that reversed to you? No, it looks straight on. Oh, because when it's showing it to me, it's backwards. I mean, when you move over to the side, the camera follows you. So we can only see it for a second. Yeah. Was it over? Tricky camera. I apologize to everybody all the time for what I look like generally. So. All right. So tell you what, we'll go ahead and get rolling here, and see if my clicker works. I got to get it in window. There we go. All right, so I'll start by saying, first of all, that I use Prezi. Inevitably, the question comes up, hey, that's not PowerPoint. What are you using? And the tool I use is called Prezi. Basically, I get a huge canvas, and I'm able to lay out images and text and things like that. And I connect various frames with a path, so there's a lot of animation. In my experience, it tends to come over just fine most of the time with webinars and things like Link. I even stepped the resolution down on my monitor, so we're pushing fewer bits across the pipe, which might actually make a difference now that Jeff's on his Wi-Fi or on his hotspot. But the animation shouldn't matter too much. You'll still get the information. So if you see my eyes going up, it's because the monitor that I'm projecting on is right above the camera. So my name is Sean McDonough. Back beginning of April, I was fortunate enough to receive an MVP from Microsoft, both in the Office development and then the Office servers and services categories, which essentially means there we go. Thanks. Which essentially means that I can do development and I'm an IT pro. And I made the mistake once. If any of you know Seb Matthews from the UK, I made the mistake of saying, hey, I go both ways, talking about development and administration. Well, Seb had entirely too much fun with that comment, and so I try to avoid making it too often anymore. I'm the National Office 365 Solution Manager for a company called Cardinal Solutions. We're based here in Cincinnati, Ohio. We're in 5 different cities. I've got a slide about that here in a second. But in any case, I do Office 365, and I've been doing a lot of EMS type work on a day-to-day basis. Still manage to get my hands in SharePoint whenever I can. So let's go ahead and zip over here. I want to thank you guys for letting me join you today, albeit virtually. This big lovable mug up here. He's big and lovable. He's sweaty too. You can't see my shoulder after that picture, but it's kind of wet.
It's like 90 degrees. It's like 95 degrees out today, so I'm sweaty again today.
I'm sure. Yeah, I mean, summer's definitely with us. But thanks a lot for letting me hook up with you guys virtually. I love to give presentations and share what I've learned, and especially in this type of presentation. Because what I tell people is this presentation is kind of like community service for some of the crimes that I've committed in various SharePoint environments. I've done some really horrible things over the years, and so I'm on work release right now, and this is one of the ways that I give back to the community. So a little bit about Cardinal. We're based in Cincinnati, Ohio. We just celebrated 20 years in business. And we're about 400 people right now, and we're spread out across 5 cities. We've got 2 here in Ohio, Cincinnati and Columbus, 2 in North Carolina, Charlotte and Raleigh, and then down in Tampa. And we do a lot of everything, like many different consulting companies. We are a Microsoft managed partner, so we're kind of joined at the hip with Microsoft, and we do a lot with cloud-based cloud-based development, cloud-based customization. So we do all sorts of things. Azure, we were Azure partner, Central Region Partner of the Year last year for a big IoT project that we did for a company up on the north side of Ohio. So we're pretty happy with what we do in the cloud space. I know that you've got plenty of really good consulting companies there like Blue Metal, but if you're ever looking for somebody from the Midwest, give me a shout. So here's what we're going to cover today. A little bit of caching 101. Most people nowadays know what caching is. But identifying, what I want to do is establish kind of a baseline definition for purposes of going forward, making sure we're all speaking the same language. I want to talk about each of SharePoint's platform caching options, because over the years SharePoint has accrued quite a few different ways to cache and hold data that impact us in a number of different ways, and I want to call each of those out. Talk about how to leverage each of those mechanisms, how to control them, maybe some pitfalls you need to be aware of while using them. Towards the end, I've got something what I call a scenarios quiz. Don't worry, there's not going to be an actual quiz. I mean, I'll ask a question, but it's really kind of to test your knowledge and communicate maybe a few extra points of information that might be of use to you. And then Q&A throughout. If something comes up that you guys want to discuss right away, or if you want to wait till the end, that's fine too. Everything I'm showing you will be available on my blog. I'm also recording this link session now too, so I'll try and share that out. So if folks want to go back and look over this, they can do that. I've had pretty good luck posting some of these out on YouTube. But like I said, I'll have a PDF of all of these different frames that I'm showing you, and you'll be able to pull that down from my blog, which is sharepointinterface.com. And I'll have that address up at the end too, so you don't need to write anything down. So let's talk about why I care about caching, or in some ways, sickly, why I love caching. I've got a bit of a Stockholm syndrome with caching, Stockholm syndrome problem. If you're not familiar with that, that's when somebody lives in captivity so long they come to, in a twisted psychological way, start to love their captors. And caching had me captive for quite some time back in the SharePoint 2007 timeframe. So back in the 2007 timeframe, we've got a Fortune 25 company here based in Cincinnati, Ohio, who chose to rebuild all of their public presence sites on SharePoint 2007 as it was being released. Now, if you know anything about SharePoint's lineage, you know that publishing and public sites were really kind of brand new with SharePoint 2007. Previously, Microsoft had a separate product called Microsoft Content Management Server 2002. They sunset that product and they rolled the various publishing capabilities into SharePoint. And so this was brand new technology at the time, and there was no playbook on how to build public sites. In fact, a lot of what we did as we went through this got integrated into TechNet articles and things like that. Now, this may not seem like a lot nowadays, but if we go back a number of years, the environment when I started doing some calculations shortly after I rolled off the project, we had a highly trafficked environment. We were seeing about 75,000 page views per hour peak coming into our farm. And when I did the math based on page load and assets that were being loaded, that was averaging at peak at about 1,000 requests per second into IIS, which again may not seem like a lot by today's standards, but roll back the better part of 10 years, and that's where we were at. We initially serviced this load with just 2 web front ends. Now those web front ends were working really hard. We eventually moved to 4 for growth, but we did it with just 2 web front ends, which, you know, a lot of people say SharePoint doesn't scale. Well, it does scale. We had to scale quite a bit. And that brings me to my final point. The reason I talk about caching a lot is because I get sick and tired of people complaining SharePoint doesn't scale. We don't hear that too much nowadays with SharePoint Online. And SharePoint has evolved to the point of being able to service quite a wide array of users and take quite a bit of load. But there was a point in time where anybody who tried to customize SharePoint, you know, they would complain that SharePoint didn't scale. And the developer in me is keen to point out that 9 times out of 10, if SharePoint doesn't scale, it's usually due to kind of questionable customizations. I don't want to point the finger at developers, but I'm pointing the finger at developers. So again, I can get off saying that because I do development myself, and I've committed many crimes against humanity in SharePoint environments. So what is caching? Well, caching can be a lot of different things, but anytime I'm looking for a definition for something, what I usually do is go to my trusty dictionary. Now, you know, this is of course a bona fide paper-based dictionary, but you can go online. Well, I pulled out my dictionary and I looked up caching. And if you look there on the page between, you know, that covers cable to cadaver, we have a definition for cache, which, according to Webster's, is a place in which stores of food, supplies, etc. are hidden as by explorers or trappers. All right, so it's worth pointing out that this is the dictionary I took to college with me, and that was over 25 years ago. Things have clearly evolved a little bit in 25 years, so my 3rd college edition of Webster's New World Dictionary is not going to cut it for the definition for caching that we need. So clearly a more contextually appropriate definition is needed. And so I chose to define caching for purposes today. You know, it can be many different things, and you're probably familiar with some of these things, you know, ICP, high throughput caching protocol, HTCP, maybe SharePoint's Blob Cache, you've worked with that. Caching can be many different things to many different people. But for our purposes today, what I'm just going to generically say is a cache is a temporary storage area where data that is computationally expensive or slow to fetch can be placed for faster access. So caching is really about taking data that might be slow to fetch or generate and putting it someplace we can retrieve it and work with it more quickly. Now there are 2 ways that this is commonly accomplished. One you're probably very familiar with. The other one, unless you work in a geo-distributed type environment, you probably don't think about too often. But the first one is the one that most people know. We take data that's on a slower medium, like a spinning, you know, a hard drive that is still spinning platter style, and we move that off onto a faster medium like memory. So it's not uncommon to have a cache, a memory-based cache, where we take things off a disk and put it into memory because we can access data more quickly from memory. Our read times are much faster, and our throughput is higher. Now the other way that we can get data more quickly is to place it closer to the point of usage. So if you consider the situation, maybe you work for a company that has multiple offices around the world, you know, a SharePoint farm exists in one place. And if you work for a company that's based in Germany and the SharePoint farm is set up in Germany, and you live in the United States in the Massachusetts area, up there in Boston, you've got to go across the Atlantic to get to that SharePoint farm. And getting to that SharePoint farm involves a certain amount of time. You've got to be routed across the ocean, so there's latency, there's time it takes to get to the farm, and at the same time, the further we go, the more pipe we have to traverse, virtually speaking, and oftentimes we suffer bandwidth constraints. So higher latency, lower bandwidth means it takes longer to get that data for use. Well, if any of you are familiar with Akamai and edge-based caching or content delivery networks, CDNs, these are all about taking data from some place that might be far away and moving it closer to the point of caching. So edge caching, such as Akamai, you know, and if I go out to Microsoft and I want to download a really large ISO file, maybe a new version of some server platform was released, oftentimes if I click on the link to do a download, if I look at where I'm downloading that data from, it's on an Akamai edge node that's closer to where I am in the country. So I have less distance to traverse, and I'm running a better chance of having a high bandwidth kind of scenario. So that's another way that we can put data closer to the point to make data access more quick, is by putting it closer to where we're actually using it. So those two techniques kind of, we use both of those with SharePoint, believe it or not. And as I go through each of these mechanisms, you'll see where that comes into play. So why do we want to do this, or at least why do we want to do this for SharePoint? Well, that may seem like an obvious question, but it's worth spelling out and pointing out how complex a series of interactions is when we go to request a page from SharePoint. So this is a simplified diagram showing a network and a SharePoint farm. I've got a web front end on the left-hand side next to the internet, and then on the right-hand side I've got an application server and of course a database below that. Now when a user makes a request, it starts out, if I say I want default.aspx in a particular site collection, I am making a request to the web front-end server. That's a single HTTP request, but oftentimes with SharePoint and most other web pages in general, when we initiate that request, we are actually starting a dialogue with the front-end servers. It may start with a page coming back, but as our browser interprets that page and identifies additional resources that are needed, things like CSS and JavaScript, images, things like that, those in turn have to be fetched from the server. So a single page request can result in any number of assets being returned to us. Now, if we look at what SharePoint is doing, each time we request a page, there's an orchestration of processes that kick off on that web front end. First, we oftentimes have heavy traffic between the web front end and the SQL Server database to retrieve any of the assets, any of the materials that are needed for SharePoint to render our page. So really we're pulling data for the site collection out of the content database. Everything from properties for the particular page we're looking at, access control lists for security, content for web parts and lists, things like that. All of that has to come from the database. At the same time, within the SharePoint farm itself, web front ends oftentimes are going to back-end app servers to retrieve any sorts of data that might be offered by service applications. Think about search. We make a search request. If our query role is running on a server other than the web front end, then the web front end has to go across the wire to make a query against search, interrogate the index, get data back for display. And that's just one example. Business connectivity services, BCS, is another good example. So any number of service applications running on other boxes could be engaged. And so there's a dialogue that's taking place between those servers. And at the same time, if we think about the service applications themselves, very few service applications exist without some form of database on their own. Search, BCS, Secure Store Service, all of these are service applications that have their own databases. So the server that houses those service applications is also going to the database or another database to pull up data that it needs. So we've got a very complex series of interactions here taking place simply by issuing a single request from a user. Now, if we drill into that even more closely, if we look at our web front end and we start to actually look at the process of rendering a page in SharePoint, things get even more interesting. Any of you who are developers are probably familiar with the page and control lifecycle that gets kicked off anytime a page needs to be rendered in SharePoint or any other ASP.NET application. So if you've ever looked at the events that are generated and the methods that fire, there are a series of them that take place in a predictable order. And in many cases, some of these happen more than once for each child control that exists on a page. So each of these bracketed areas you can think of as occurring multiple times, once for each child control. But really, this isn't the whole sequence of events that take place. The only way to really show the whole sequence is to kind of turn this on its side and show you end to end. So based on that diagram, you don't have to see what everything is. You just need to know that every one of those rectangular pills is a distinct operation or method call or event being fired. And every time we render an ASP.NET page, this entire sequence of events takes place. So based on the sheer number of events and methods and things that are happening here, you've got to believe there's a way to optimize this process, or perhaps skip over certain steps where the outputs are known to be true most of the time. And this is where caching can come into play to help us quite a bit. So the ultimate goal of caching is better performing, more scalable sites, and ultimately a better user experience. We're doing this for a better user experience as well as to improve the throughput of our SharePoint environments. Now, if we look at SharePoint, there are quite a few different caching mechanisms that are available to us. Some of them are common across all versions. Some of them exist only within certain versions of SharePoint. We've got object caching, blob caching, page output caching. Some of these sound familiar, probably, and some of them may be confusing. The terms are very specific. There was a time on TechNet when a lot of what I'm going to be sharing with you was just being added to TechNet. TechNet used to not be a very good repository for these things. And even Microsoft would occasionally mix terms and make mistakes talking about page object caching and things like that. There's no such thing as a page object cache. You're either object caching or you're page output caching, but you can't mix the two. So the documentation online is pretty good now, and I've got a number of references at the end. But this presentation will also cover those various mechanisms, at least at a relatively high level. So what the fine print says there, I have two versions of this talk that I typically get. The one that I've got right now is more configuration based. It's targeted more at admins and IT pros. But I have a developer version of this talk where I talk about implementing some of these mechanisms under the hood within your own code. The small print text here is only to say that I'm not going to cover things like the web part cache, the ASP.NET cache. If any of you are familiar or have ever heard of the iVary by custom handler interface that's used to override key generation for page output caching, I don't get into those things, post-cache substitution, fragment caching. I cover many of those in a developer's talk that I give, and if you have some interest as a developer in some of these things, when you go to look for this presentation online in my resources area, just go back through the various conferences and areas I've spoken. You can pull down a previous set of slides that contain the developer version of the talk, as well as Visual Studio Code that you can download and work with yourself. But our focus today is going to be more on the configuration-based stuff, which, of course, admin and IT pros are typically interested in. But even power users may find some of this to be of use to them as they plan their pages and maybe tweak things. So that's what we're going to focus on. And unless I specifically note otherwise, what I'm sharing with you applies across more or less all versions of the platform right now, going back to 2007. We will have some instances where we're looking only at 2013 and 2016, as well as we've got an instance where it's just 2010. But like I said, unless I say something otherwise, it is going to be all versions. Oh, let me put my cursor back. So SharePoint interface is my blog. I'll have that again at the end, but just to throw that up there in case anybody wants to go digging. So let me give you a short story, because I told you that this presentation in many ways is penance for crimes I've committed in the past. And like I said, I'm on SharePoint work release right now, and I'm allowed to go out and talk about this story for my freedom. So when I started doing this implementation for this Fortune 25 company, I started out in an admin role, and when I got there, they didn't have anything put together. They weren't even a Microsoft shop. This technology was all new to them, so I started by planning their farm environments, and I started in an admin capacity and ultimately transferred over to do more with the software and development side. But when I was putting the farms together and I was trying to figure out how we were going to service what we expected to be a very high user load, I started wondering, and I'm thinking, I know that SharePoint has caching mechanisms built in, but what are they? How do they work? Probably the most important question I had right out of the gate, is there an on button? Is there something I need to do to turn this stuff on? Maybe some of you are in the same boat, wondering, you've heard about these caching mechanisms, you don't know what may actually be on and what's not on. So my very first question was, do I need to do anything to leverage these mechanisms. I suspected I did, but I wasn't sure, and like I said, the documentation wasn't all that clear. So let's talk about on buttons and at least what enables caching within SharePoint. So I have up here a picture of a site collection, and I have the settings page open for that site collection. And if I look under site collection administration, I'll find site collection features. Many of you have probably been to this area to turn features on or off in your environments at the site collection level. So if I click that link, I get a list of features that are available to the site collection, as well as some indication of whether those features are active or can be activated. Now, if I look down, what I'll see is the SharePoint server publishing infrastructure. And if we have anybody who's still on SharePoint 2007, it is not the SharePoint server publishing infrastructure, but the Office SharePoint server publishing infrastructure. And many of you are probably familiar with this. You've had to turn this on to enable certain things. Of course, publishing in your environment, but maybe metadata-based navigation or something like that. And in order for us to leverage many of the caching control surfaces that show up for administrators, we have to activate this feature. This also, by activating this feature, wires in some of the extra plumbing we need to use certain caching features. Now, it's worth pointing out, this doesn't happen too often nowadays, but in the 2007 and 2010 timeframes, this was more common. If you only use WSS, Windows SharePoint Services, like version 3, or SharePoint Foundation 2010, you're not going to have this feature available to you. Publishing is a quote-unquote premium feature, and you need a paid version of SharePoint to use this. So without SharePoint Server Standard or SharePoint Server Enterprise, you do not have access to these caching mechanisms. So this is the awkward point in the talk where I go, well, if you're one of those free version people, the rest of this might not be of interest to you. Hopefully we don't have too many people, and with a little luck, we don't have anybody in that boat right now. I usually look for a show of hands, so Jeff, you'll have to see if anybody out there is grumbling and flipping off the screen right now. You see any of that?
Nobody flipping up screen. How many people running Foundation or WSS? Zilch.
Good.
All right.
Usually, because those people usually leave in a huff and destroy my ratings and things like that. So I'm glad you guys aren't in that boat. All right, so how does the plumbing actually work? I told you when you flip the feature on, that enables a lot. Well, what actually happens? So in order to understand what happens, it pays to start by looking in our web config. And if you're not familiar with the web.config file, every .NET web-based application has a web.config to drive configuration settings for ASP.NET, for the application, for a variety of other things that tie into the page rendering pipeline. Now, this is a section of a web config at a very high level. We'll drill into it in a second. The reason I say it's a section is because I tried to actually take an extended image of the entire web config, and this program that I use, Prezi, to do the presentation, yeah, it choked on that image. I imported it and the thing fell over and died. So I actually had to just go with a small section. But in any case, if we drill into that file and look at the HTTP modules that are set up for the server, if you're not familiar with what an HTTP module is, an HTTP module is a section of compiled code that can be wired in so that every request that ASP.NET receives for a page or really anything else, these modules run and have a chance to influence what happens during the rendering of the page. Everything from adding content to the page, kicking off other processes, doing security checks. There are multiple different ways that an HTTP module can influence the output from the page rendering lifecycle. Now, the last module you see in the list there is called the Publishing HTTP module. This is wired in for you. There's nothing special you need to do. But as its name suggests, the Publishing HTTP module implements publishing capabilities for SharePoint. The Publishing HTTP module is also where most of the cache control mechanisms and plumbing reside. So by wiring the HTTP module in, all of the cache control code is there and available. Now, whether or not you have that turned on or not, that is various caching mechanisms turned on, doesn't really matter. The fact that, oops, I'm zipping ahead here a little too quickly. The fact that it's in line there means that there's nothing special you need to do besides maybe hitting check boxes in the site collection admin settings, or as we'll see with the blob cache, you control the caching by making additional entries to the web config itself. But this publishing HTTP module is where all the magic happens from a caching perspective. So what I like to do as I get into the caching mechanisms is show how each caching mechanism might influence a page or a section of a page that gets rendered. So what I have here is a mock-up of a balsamic mock-up, and I'm sure a handful of you at least work with that. Balsamic's really good for building mock-ups of pages and other user interfaces. I used it to build this fake SharePoint site here, which looks a lot like the 2007 SharePoint publishing page that you get by default. And as we go through the caching mechanisms, I'm going to highlight different pieces of this page to show you what might be affected. So let's start off by talking about object caching. Object caching is a very low-level form of caching, affects a lot of different things, and very non-specifically, what I say about object caching is it speeds access to frequently referenced structural property and result data. How's that for a non-definition? Yeah, it makes things go faster. That's what we want, right? All right, so that's very generic. Let's talk about what might actually be impacted. And so as you see the balsamic mock-up here, you've got a number of arrows and circles and things like that. I'm going to go through each of these because each of these are things that object caching influences in some way, shape, or form. So if you think about navigational data, in a SharePoint page and in an ASP.NET page in general, we have what are known as navigational providers. Navigational providers use what are called sitemaps to determine how to render menu items, breadcrumbs, things like that. SharePoint is no different. Anytime a page is visited, a sitemap is pulled up, and that sitemap, which is used by nav providers, gets cached in the object cache because building sitemaps is very expensive from a back-end process perspective. Every time we visit a navigational node in a SharePoint page, to build the sitemap. So you can think of this as anytime SharePoint needs to go through a site collection hierarchy, every sub-site it looks at, every page it looks at, requires 8 SQL calls. So take the number of nodes you have in your hierarchy and multiply by 8, and that's how many SQL calls need to be made to build a sitemap. So it's very expensive. It makes sense to take this data because it doesn't change very often and store it in the object cache. So the quick launch is the same way. It's really just another representation. It's a local representation of the sitemap based on where we are in the navigational hierarchy with our current page. So it also uses that sitemap which exists in the object cache. Now certain properties that don't change very often, like a site title, also get cached because if you think about it, once you set the title for a SharePoint site, it doesn't change very often. It's usually just a straight read operation. And so it makes sense to take those properties which don't change very often and put them in the object cache so that we're not constantly going out to the content database every time we need to use that property. Now, if any of you use the content query web part, and users love content query web parts, the content query web part from an end user perspective is where we really start to see benefits from object caching. Because if you understand how the content query web part works, one of the best things about it is we can use it to aggregate data from across sites and subsites within a site collection and across lists as well. Every time a content query web part needs to display data, if data were not cached, SharePoint would need to run these very expensive cross-site and cross-list queries to aggregate the data that gets shown through a content query web part. Since those operations are very expensive and time-consuming, it makes sense to take the result from those query operations and store them in the object cache. That way, we're not constantly going out and rerunning the same queries over and over and over again. Now, if any of you are in SharePoint Online, you may have gotten advice not to use the content query web part. If anybody's seen me talk about the content search web part, I tell you that particularly in an online environment, you're better off using search, like the content search web part, than the content query web part. That's because caching mechanisms we can rely on in an on-premises environment, which is solely ours, we can't rely on in the online environment, which is multi-tenant, where you're crammed in with hundreds of your closest friends and all their site collections. Caches get busted, they fill up, ejections frequently happen. Preloading of caches is a very unpredictable process, so we can't rely on the object cache in the online environment. So things like the content query web part oftentimes bog down pages online, and you're advised to switch to something like search, which is very quick. But presuming you're in the on-premises environment, the content query web part will, by default, starting with SharePoint 2010, store results from cross-site, cross-list queries for 60 seconds at a time. After 60 seconds at a time, that cached data is invalidated and the query gets rerun. Now, the interesting thing is, if any of you are still using SharePoint 2007, SharePoint 2007 did not enable this behavior by default. So when I show you how the object cache is configured here very shortly, I'll show you the button that is set by default in 2010 and beyond to cache for 60 seconds. You can go in with SharePoint 2007 and turn that on. And it's the closest thing to a go faster button you're actually going to find with caching. So I'll show you that here in just a second, but know that from 2010 on, cross-site, cross-list queries that are used by the content query web part have the results cached for 60 seconds at a time. Now, if any of you are using publishing pages, and that's what I mean by layouts here, not underscore layouts, not that folder, not that virtual folder, but page layouts themselves that describe where content regions are on a publishing page. The structure of those regions and the structure of those layouts also gets cached for faster access. So at a high level, we can see that the object cache affects a lot of different things, some of them fairly subtle, some of them not so much, but it touches many different things in our SharePoint environment. So when we run the numbers on the object cache, this is backed by memory, so these properties and this data get stored in a region of memory that's allocated for the object cache. It is turned on by default. This is one area of caching you do not need to turn on to make use of. And the default allocation is 100 megabytes per site collection. Now this can be controlled, as I'll show you, through site collection administration settings. So site collection admins can get in and tinker with this. Well, this was available to them in 2007. In 2010, Microsoft got a lot of feedback, or I should say by 2010, Microsoft got a lot of feedback that caused them to implement a new control surface for that object cache. We need to drill into the web config to find it, but there's an object cache element in the web config where admins can override the allocation for the site collections within a web application. The reason this was put there is because unknowing site collection admins might tinker with memory settings that would adversely affect everything running on the server. And most admins I know who take care of the servers do not like the idea of empowered end users tinkering with their memory settings. So this is the final word, and this trumps anything that might be set within site collection administration settings within the SharePoint interface. So speaking of the site collection admin settings, let's actually drill into the site collection object cache settings we have available to us to see what's available. This is the page that comes.
Hey, Sean, hold on one second. We have a question.
Alrighty.
Do you want to come up? Do you want to come up here?
Oh.
He can't hear you over there.
Oh, yeah. Do you know it's my voice?
Speak into the computer.
Hi, Sean. Just quick question. On your previous screen, right above where you were showing the object cache, there was the path for blob cache. There was a number 14. What does the 14 mean?
We're going to cover blob cache next, but the 14 is the version of SharePoint. So that gives a dirty little secret about this screenshot. 14 was the release version for SharePoint 2010. So that's right. Yeah, right? Or was that 7?
That's 27.
Okay, that's what I stopped referring to it. We used to have, the 14 Hive and the 12 Hive, and all that dated nomenclature. But yes, the 14 is a reference to the version of SharePoint. So if you happen to be running an upgraded server that maybe went, well, it's less with 2013 because you can't do an in-place upgrade. But if you went 2007 to 2010, you may have noticed two different paths in your blob cache if you happen to have it enabled in both places, one for 12, one for 14. So yeah, it's just a version thing. Very good eye. We'll talk about blob caching here in a little bit more. But what I want to do is let's cover the object cache settings first. Now the nice thing is Microsoft has done a decent job starting with 2010 of giving us explanations of what these settings are. Prior to 2010, if you're in the 2007 era, there was nothing. It was just a header, and you had to guess at how it was used. And that often led to problems, which I'll talk about here in a second. So the first setting we have is the object cache size. And like I said, by default, this is set to 100 megabytes for the site collection. So this begins the painful story part of our presentation. Like I said, this is penance and therapy for me altogether. I want to tell you a painful story about an admin named Sean McDonough, who in an effort to reclaim some memory on a SharePoint 2007 server, observed that each web application had 100 megabytes allocation for its object cache. Now, at the time, things were poorly documented. I thought that this was reserved memory, and given the number of web applications running on the server, I thought I can reclaim a lot of memory by dialing the object cache down, because I didn't think I was putting all that much into memory for the object cache. I mean, certainly I could reclaim some of that space. So I dialed that 100 down. Now, I'm not going to tell you just how far I dialed it down, but suffice to say, I was very aggressive, okay? I cut the memory way back. And nothing broke right away. Everything seemed to be working. And so like most good admins, I promptly forgot that I ever made the change. Life went on. Week, 2 weeks later, we started running into a problem in the environment where the server would just mysteriously stop processing pages and collapse. And this was happening it was never very frequent, but it would happen at the weirdest times. Sometimes it was the middle of the night, sometimes it was during the day. And since we only had 2 web front ends, we didn't have sufficient headroom on the servers so that when one server went down, the other one could handle the full load. So we basically got cascading failure of the entire system every time a server went down. Well, we worked on this. We got Microsoft Premier Support involved in this. Premier Support, ultimately, they're like, we don't know. Escalated it to the product team. I got to work directly with the product team, some really good folks there. At the end of the day, after many memory captures, after much analysis, you know what it was traced back to? Everybody at once now.
Object cache.
Yeah. Some stupid admin went and dialed that object cache all the way back. And what was happening was the object cache was filling up. And then when the object cache gets full, as new data comes in, old data gets ejected. Well, over time, these ejections lead to fragmentation of that memory. And there is a garbage collection and a reorganization process that happens with the object cache to basically crunch all that back down and clear up larger contiguous blocks of memory. Unfortunately, this collection and cleanup process locks the web page processing pipeline. It's a single-threaded process that blocks any page rendering. And it takes a little bit of time, measured in seconds. But if you happen to have that happen when you're in the middle of a large spike of load, basically your ASP.NET queue can back all the way up and the server tips over. Now, in my defense, Microsoft admitted there was no way at the time I could have really known this without using some really obscure counters that don't seem to add up at all. But I'll have some tips at the end on how to actually look at that. It's less of a problem nowadays. But the takeaway from all of this is don't dial memory settings down until you understand exactly what's happening. Many of these settings you can unknowingly get yourself into a lot of trouble with if you just start monkeying with them. That's true with any type of memory setting on a server. It's usually safe to allocate more memory. You don't often starve other processes, but deallocating memory for something when you don't understand how it works can lead to really unpredictable behavior, as my story is proof of. So that's the lesson from this one. And like I said, I'll give you some performance counters a little later on to watch. So let's talk about another setting you have, the object cache reset. This doesn't get used too often in production scenarios. This is more of a developer thing. But the object cache reset can be used to flush either, if you've got a multi-server farm, you can choose to flush a single object cache based on the web front end you're connected to. Or you can force all servers in the farm to flush their caches by hitting a checkbox and then hitting OK at the bottom of the page. Like I said, in normal runtime scenarios, you don't monkey with this, but developers who want to test the results of queries and things like that, they may not want to wait for data to lapse out of a cache, and so they may elect to flush it rather than turning caching off altogether. Really, it just comes down to preference and what you like to do. There's another setting called the cross-list query cache changes value. Don't say that 5 times fast. It will tie your tongue. Cross-list query cache changes. And this is the setting that basically says, yes, when I run a cross-list or cross-site query, as I do with a content query web part, I want to cache the results of that query, in this case for 60 seconds. That's the default behavior. This is the button, if you're still using SharePoint 2007, that you want to go in and switch from check the server for changes every time the query runs over to use the cache result of a cross-list query for this number of seconds. This will start engaging the object cache for your content query web part and allow you to reuse results for 60 seconds. Now, the other side of this, of course, is your results will be used for 60 seconds. So if you have data changing over so frequently that you can't stand to have results that are a minute old, well, you may want to adjust this. But for the overwhelming majority of scenarios that I've dealt with, having results cached for 60 seconds doesn't hurt anything. Now, there's a cross-list query results multiplier as well. Now, this number, what it basically does, here's how it works. The number by default is 3. If I run a query to display 10 results, for instance, through a content query web part, what this multiplier says is, rather than pull back 10 results to store in the cache, I'm going to pull back 10 times 3, which is the multiplier, and pull back 30. Anybody have any guesses as to why that is, or why we would want to do that? Silence.
Ants. Nothing.
Nothing. Okay. So I'll cut straight to the chase. The reason you would want to multiply it is because when results are pulled back and stored in the cache, results are pulled back for every combination. Basically, they're pulled back without regard to security. The idea here is if you happen to secure various lists, various items that might be shown, there's a decent chance if I have a reduced permission set or I'm not allowed to see certain items or certain lists, I may not be able to see some of those results once security trimming is performed. So this number is a form of insurance that says, hey, if I need to show 10 results, I'm going to pull back 30 thinking that there's a decent chance that of those 30 that I pull back, once I take into account security trimming and other permissions, I'll at least have 10 to show. Because if I don't have 10 to show, guess what? I have to go and rerun that query to pull back more results, which not only kills caching, it slows the entire process down. So this is a multiplier. And we want to tinker with this multiplier based on the type of scenario we're in, or we may want to tinker with it. So for anonymous users, if you think about the case where if you've got a publishing site and you allow anonymous access, every user who comes into the site anonymously is functionally the same user. There's no username, there's no qualifying information. Every user is the anonymous user. And so in those situations where we have zero variation based on access control permissions, we may want to reduce that multiplier and up the cache duration, because results can that's typically a heavy read situation, not a lot of read-write activity. We can cache things for longer, and we don't need to cache as many because every user is the same. The flip side is true if we're using authenticated access, especially if we're in a per site or per item security sort of situation where lists have a lot of variation in the permissions that are applied to items or across lists and libraries. The more variation we have, the more results we may need to pull back and cache in order to ensure that we can pull a valid number out after security trimming to show to the current user. that make sense to everybody? Does anybody have questions on that? Okay.
Getting nods and thumbs up, so you're good.
Nods. Good deal. All right. So that's the object cache. And if we look at what the object cache affects and how it affects the farm, well, first off, anytime we do object caching, we're cutting down on the number of queries that we're running against SQL Server. So right away, we see some reduction in load, typically from the web front ends to SQL Server, and we're pulling less data back. So we see a moderate reduction in activity there. At the same time, by caching results, particularly if we're using a lot of content query web parts, like I said, they're computationally intensive when they've got to run those cross-site, cross-list queries. We cut down a lot of that churn if we cache results for a period of time so that we're not running the queries so often. So we reduce processing on the WFEs to some extent. So at the end of the day, object caching is really, the reason it's on by default is because it's generally minimally invasive and it tends to help everybody. You can turn it off if you want. I don't suggest it, but you will get some modest improvements through object caching. So next up, we have the blob. Blob caching. I love blob caching. If you look on my blog, SharePointInterface.com, you'll find I've written a bunch of articles on blob caching over the years because I've literally gone under the hood and dissected it, run Reflector against blob caching to figure out exactly how it does what it does, because I've had to tinker with it on many different levels. And don't worry, it's not this kind of blob. This is not the blob that ate New York or anything like that. Blob is a binary large object, and blobs manifest as items that we upload to SharePoint. Anytime we upload a document or an image or some other form of binary payload, basically what SharePoint does is it puts it in SQL Server into an unstructured section of SQL Server where you have to store these objects that are kind of unwieldy and unmanageable from a database perspective. And since they're so large and oftentimes take time to fetch, blob caching helps us work with these more efficiently than if we had to go to the database every time to get them. Now, of course, when I was doing this and putting these images on the page, I couldn't help but have a little bit of fun with this. You got to understand the way the mind works very late at night when you're working on presentations. You start to get into these weird matchups, like Wile E. Coyote versus the Terminator and those sorts of things. Well, I thought, what happens if we have a blob as viewed by a database person? And of course, the blob that most people with modern cinematography are familiar with, the one that tends to eat and kill everything. What would happen? Who would win? All right. So we had a little fight night matchup in my head. The blob on the left, of course, chews up database space. That makes it kind of nasty. But let's face it, the blob on the right, that consumes entire cities. So I think the point goes to the one on the right. The blob on the left is hated by database admins. Like I said, these mess up databases. They're really ugly in SQL Server. Of course, the one on the right is the bane of all humanity. Well, pick your poison there. The one on the left kills attempts to organize database pages and extents. That's why database administrators grumble about them all the time. The one on the right kills anyone stupid enough to get in its slow-moving way. And let's face it, most of these movies, the people eaten by a blob, they can get out of the way. If you're caught by the blob, I got no sympathy for you. The one on the left can be conquered with RBS. You might have heard of or use remote blob storage. Takes those blobs out of the database where they're not stored efficiently and puts them on a file system so that the database, the content database, contains metadata, properties, and pointers to the blobs, but it remains nice and structured and organized. Now, the one on the right, of course, is wiped out through military action sometimes. Okay, so once we actually do the math, the one on the right, clearly the winner. Can't argue that. No matter how much database admins scream, the one on the left is really not hurting too many people. The one on the right, however, would win in a fight. Thank you for indulging me in my little late night activity. Let's get back to our regularly scheduled program. So this type of caching, blob caching, is known as disk-based caching, and that gives us a little insight into how it actually works. So disk-based caching or blob caching, what we're doing is we're taking blobs out of content databases and we're storing them on the web front end servers so that we don't have to fetch them from SQL Server and pull them across the wire every time we need to use them. Now, if we look at a SharePoint page, anything that's in yellow is typically going to be covered by blob caching. And as you can see, there are a few specific items that I've got highlighted But if you look at the pattern here, it's pretty much anything that's a media type, like images. It extends to CSS and JavaScript. Any type of asset that remains relatively static and forms the kind of payload of a SharePoint list item or maybe an image, something like that. It's worth noting that caching, blob caching, can be extended to cover file types that aren't inherently covered with the out-of-the-box settings. And many admins have probably tinkered with this, particularly in previous versions of SharePoint, to extend blob caching to cover other types of files that weren't listed. You know, in the past, things like Flash animations, PDFs, those were common adds. Nowadays, SharePoint caching, blob caching is already set up to cover these, but we can easily extend it. And I'll show you how here in just a second. Now, if any of you started with SharePoint 2013 of using the image rendition service, and you tried to leverage image rendition service without turning the blob cache on, you probably got this little note in the upper right-hand corner. The blob cache is not enabled in this web application. Image renditions will not be generated until the blob cache is enabled, yada, yada, yada. The reason for this is the image rendition service is server-side processing of images that are stored in SharePoint. Those images that are processed, whether they're resized, whether we're taking a subset of the image and storing it, those images that are created by the rendition service don't go back into the content database. They're actually stored in the blob cache. So if you have the blob cache turned off, the image rendition service can't work, and that's why you get this message. So that's what blob caching covers, lots of images and larger binary payload types. So let's go ahead and talk about how it actually works. Since it's disk-based caching, it's probably no surprise for me to say that it's backed by disk. It is turned off by default. Now, it is very easy to turn on. All you have to do is flip a simple attribute in a web config setting. And I'll show you how to do that here in a second, but there's things you need to do before you do that. The default allocation is 10 gigabytes per IIS site or web application zone. That may seem a little funny to you. You know, I talked about the object cache and I said it's 100 megabytes straight away. Well, the reason that we have different potential allocations for the same site collection is because it's managed at the web application level. And if you think about web applications, when you provision a new web application in SharePoint, you get what? You get a new IIS site, and with that, you get a new web config file. Every time I extend a SharePoint web application to a new zone, I get a new IIS application and another web config. So the same site collection, if we use SharePoint's default zones, we have 5 potential zones, right? We have default, intranet, extranet, internet, and custom. Those are 5 zones. 5 potential web config files, 5 potential sets of settings. And it's not uncommon in many publishing scenarios to actually have different blob cache settings based on how we're accessing data that's in a site collection. For instance, content editors will come through the default zone, and oftentimes, since we want them to see the latest and greatest without caching, we'll turn off blob caching on the default zone. But if we expose that to the outside world as maybe a public site where everybody comes in anonymously, it may make sense for the internet extended zone, assuming we extended it to the internet zone, to turn on blob caching. So we can actually establish different types of caching based on the zone that people go through, at least for blob caching. Now this is controlled, unsurprisingly, like I said, through web config settings. So let's actually go back to a web config and dive in a little bit. And as was pointed out earlier, the blob cache setting exists by default just above the object cache setting. And it has a number of different attributes that are set for us by default. And it's worth looking at these attributes to understand how it's controlled. So let's look at the default blob cache elements. Now, if any of you go back with SharePoint administration, back to MOS, Microsoft Office SharePoint Server 2007, we only had a handful of attributes. We had a location, a path, a max size, and whether it's enabled. And if we look at the path, we see 5 different file types in there: GIF, JPEG, PNG, CSS, and JavaScript. The blob cache.
We have another question.
Yes.
We have another question.
Hi, Sean. Quick question. Going back to the web config file when you showed the path, does the order of the file types matter, or is it arbitrary?
It is arbitrary. And so I'll go out. We'll get into each of the attributes here in a second, and I'll point out exactly what comes into play and how it goes. That's a good question. The order is arbitrary, but the format is very specific. And I'll talk about that more in just a second. So good question. SharePoint Server 2010, we got a much larger path, and we'll notice that the blob cache actually picked up an additional path qualifier to make sure, instead of C blob cache, it's C blob cache 14 to ensure that we don't collide if we happen to upgrade the server with any previous blob cache that may have been in use. And once we got to 2013, the only thing that really changed was the path got extremely long. We picked up all sorts of additional support, particularly for like audio files. We got a whole bunch of WMA, OGG for OGG Vorbis, ZAP files for anybody who was doing Silverlight. So we picked up a whole bunch of extensions, but really the format and the general structure remained the same. So let's actually look at those attributes. And the common ones that are set, there are more than these, but the common ones that are set are located down the left-hand side. What I generally tell people, if you're looking for additional attributes and you discover various polling interval attributes and things like that, if you're messing with those, you're playing with fire, because those affect the underlying operational mechanisms that background threads and things like that use to work with the object cache. I don't recommend tinkering with those. They are hard to find specifically because most people don't need them. But the common ones are here. The first is enabled, and this is true if the blob cache is turned on, false if not. We saw that by default it's false. So here's a tip. We'll get back to that. We'll get back to the enabled in a second, but just one thing worth pointing out. I don't know if anybody's still on 2007. This was more of a problem in those days. In order for things to show up in the blob cache, they have to be associated with a list or library. Back in SharePoint 2007, and it's kind of faded since then, but people can still go out with SharePoint, look at the virtual file structure for a SharePoint site, and place different files in that virtual file structure without putting them in a list or library. Well, those loose files, if you insert them through SharePoint Designer or some other mechanism like that, they don't exist in a list or library, and since they're not in a list or library, they can't be blob cached. SharePoint needs change token information from lists and libraries to do its thing. And when you put files in loosely, they don't get that, so they don't get picked up. So this is just a small pointer. Now, back to the enabled attribute, which I was talking about. Here's a recommendation. By default, the blob cache ends up on your C drive. Most admins I know don't like the idea of large, growing, temporary file stores chewing up all their C drive space, all their system space. Put it someplace other than C. On a data drive, most servers have data drives in addition to their C drive. Put it there. The only hint is that location needs to exist on every web front end in your environment, because this is a local path specification. So if you put it on an E drive, you need to make sure that every web front end has an E drive. Otherwise, the ones that don't are going to break. Now there's a location, and this is the path to the area in the file system where cached items will be stored. And like I said, by default, that's the C drive. One thing you also need to do, make sure when you're setting the blob cache that the allocations that you add up, I think I'm a little ahead of myself here. Yep, I'm already doing size information. Shame on me. So I'll tell you about it anyway. Size information. When you're setting the size of the blob cache, make sure across all of your web applications where you have a blob cache turned on that when you add up the allocations, you're not over allocating. That is, don't allocate more space than you actually have drive space. I've watched people run drives out of space and crash SharePoint and the entire server when caching data gets so voluminous that there are nearly no bytes free on a drive, and so the server tips over because it can't, make use of space. Typically on a C drive scenario, it's a double whammy. So just make sure you add up all your allocations. Now let's go back to that path attribute for just a second. The path we talked about, the question was, does the order in which the various file paths are specified make a difference? The answer is no, it does not. That path itself, if you look at the format, it may be a little strange to non-developers, but that path is something called a regular expression. Regular expressions, you can read up on them. They are a very cryptic language that sort of, I'll say right out, it's difficult to pick up. Regular expressions, though, are very powerful. They're very powerful in allowing us to match text and patterns of text in a string. And so if you think about every time a file is requested from SharePoint, on part of that HTTP request is the URL, which includes the item like default.aspx or core.js, the particular file we're trying to retrieve. The path is a regular expression that gets run against that entire URL. If a match is made, then the blob cache knows to take action on whatever that asset is. And the way that the regular expression is specified in the default blob cache element is you've got a number of file extensions separated by pipes. So the regular expression, if you evaluate it using a regular expression engine, says, give me any URL that ends in one of these extensions. So it's simple enough for you to go ahead and add additional extensions for different file types just by adding them to that string and separating them by a pipe character. You can, by the same token, pull them out. And by doing that, you increase the number of matches or decrease the number of matches correspondingly that'll happen. Now, if you're really good with regular expressions, you can get very creative with this mechanism and write more complex regular expressions that perhaps consider more than just the file name extension. You could look at part of the virtual path to see if it's coming from a particular document library and exclude certain document libraries, for instance, from being serviced by the blob cache. If you look through blob cache articles in my again, out on my website, out on my blog, I give one simple example of this when I talk about, do you know what's going to happen when you turn the blob cache on? But for any of you who are good with regular expressions, you can do whatever you want here and get very creative. We talked about the size for just a second. That's maximum disk space that the blob cache can consume. And then finally, there's this max age attribute. Now, those of you who are astute and who have looked at the blob cache element before have not seen the max age there by default. It's not specified. It is the client-side duration in seconds that downloaded blob cache items will be stored in the local browser cache on your system. It's not specified by default. That doesn't mean that it isn't in play. If you go back to the early days of SharePoint 2007, initially, without specifying a max age, the max age was 0. In essence, saying that items that were cached in the blob cache, they'd be stored locally on your system, but the browser would call back to SharePoint every time it wanted to use that item, and if it changed, it would pull a newer version down. Otherwise, SharePoint would return a 304, which that's the HTTP code for not modified, and so the browser cache the browser would pull that item out of its cache and use it in the page without transferring it from the server. Somewhere in the 2007 timeframe, after a number of patches and CUs, that max age got changed under the hood to 86,400 seconds. That's a very specific number. 86,400 seconds is 24 hours. So by default, when an item is pulled down that is served from the blob cache, it's going to be stored in your local browser cache for 24 hours. And during that period of time, the browser is not going to call back to SharePoint to see if it has changed. It will simply use its local copy. This is very important behavior because as you start tinkering with the max age, this can be both good and this can bite you if you think about potential upshot of what this means. Your browser's not going back to SharePoint for the asset, but instead reusing it locally. Now, I'll get into a little bit more of that in a second to understand and show you some bad things that can happen. But one thing worth pointing out is anybody who starts looking at the blob cache pretty quickly realizes that there's a particular format in the server's file system where those blob cache items are located. It's very easy to find an item. If you want to flush the blob cache or delete cached items, do not just go into the file system and delete them. You'll see them there and you'll go, oh, if I kill this out, it'll be pulled from the content database again and I'll get a fresher version. No, you won't. There are tracking files that are at the root of each blob cache site collection node that are basically lookup tables and various tracking files of serialized .NET object types, various lists and libraries that match up the blob cache items to the last known change tokens when they were brought in from the content database, things like that. If you kill an item out of the blob cache, instead of pulling a new one in and using it, SharePoint is going to give you a 404. So if you wipe out files in the blob cache, you're going to get a bunch of broken red X's on the page. If you want to flush the blob cache, use Powershell, which is valid for any modern SharePoint instance. You can look it up very easily. If you talk about flushing the blob cache, Powershell, you'll find it on TechNet. If you happen to be using 2007, there was no easy way to do it. I have a mod out on Codeplex. I wrote an extension, a solution package that actually wires flush support into your site collection administration settings. So if you're still on 2007 and you want an easy way to flush the blob cache, look on my blog. You'll find the solution there, and you can go get that and add it. It's not too often that people need that nowadays. So I know I've been talking for a bit. I'm going to get into the max attribute. Jeff, how late do we go?
As late as you want, but we have the space until 8,
okay.
Roughly.
All right.
So.
I don't want to race through things if I don't have to. Just a survey of the audience. Is this good information? I've got plenty more, but is there anybody who's wanting me to cut to the chase right away?
It's awesome. It's good. Thumbs up. Nods.
Okay, we'll keep going, and then, you know, if I start to get a little too long, you let me know, but I'll keep track. I just had my little, this is my pointer, and it has a nice little buzzer that lets me know when I'm starting to get to time. So about the max age attribute. Now I said that this determines how long items are cached on your local system. And it's worth pointing out that caching on the local system persists beyond the current browser session. So if I close the browser and come back in, guess what? Even though I've got a new session, these items that come down from the blob cache have a public cacheability header. So they stay on the system even after I've closed the browser. Well, what does this mean? So consider a SharePoint page. When you go to pull that page down, now let's say I start from a completely flushed browser cache. I've gone and cleared my history and all the local objects and things. I go and visit a site collection, hit default.aspx, and pull that page down. Now the blob cache is enabled, so items are going to come down and get stored locally, but we have to go and fetch them, of course, the first time to have them locally. When I fire off that request against a page I know really well, it generated 115 HTTP requests. Now, that may seem like a large number, but if any of you have ever gone in with Fiddler or IE's debugging tools, you've seen that, yes, the page does come down as a single request, sometimes after a redirection, but there is a lot that needs to come down to support the rendering of that page. JavaScript, CSS, other image files, things like that. In the case of the page that I'm familiar with, it's 115 requests. Now, I went in, I closed my browser out, okay, so I've fetched everything I need client side. I opened a new browser, and then I went out and hit that page again. Anybody want to guess as to how many requests were actually generated to render that page?
Nope.
Nobody wants to play. Okay, that's fine. You guys are all probably full of pizza right now and very
4.
happy. 4. 4 is actually a pretty good guess. That's exactly what it took, Jeff.
I get a sticker.
You do get a sticker. That's impressive. Yeah, people usually guess. But if you look at that real closely, it's probably hard to see. But the first request is a 302. So it's a redirect from the root to the pages library for default.aspx. There's a tracking cookie on there that has a no cache header. And then there's a JavaScript callback, I believe. So 4 requests that happen, but everything else is pulled out of the browser's local cache. Now think about this in a WAN scenario where I'm going maybe overseas to get a page. This can greatly improve my end user experience because once my cache is full, which of course, you know, the first page load is always going to be painful, Subsequent reuses of those assets will be served out of my local cache without HTTP requests back to the server. So hey, this is really awesome. But of course, this behavior can work both for and against you. Now, okay, I'll cut to that in a second, but here's the thing. Now, this client that I was working with, we set up blob caching for them. This was a public-facing site, so the content didn't turn over too often. And I showed the client how this works, and they said, that is really cool. That's awesome. You know, we profiled sessions, and I showed, and everybody was happy. We cut down because, you know, internet pipe is still expensive, and back then it was even more expensive 10 years ago. So we were actually minimizing traffic to web front ends and the amount of pipe that was being chewed up. Unbeknownst to me, the customer later, after I had moved on to something else, they went and changed that blob cache max age. They changed it. Like I said, the default was 86,400 seconds. They did the computation and they changed it to 365 days. Okay? So for a full year, once something had been downloaded, the browser was not going to call back to SharePoint for that asset. The idea here being, hey, we can store all this stuff locally for a year. We're going to totally cut down on all the traffic. And it did. It did a wonderful job of that. But there was this small problem. About a week after they made this change, the content editors started noticing that they would put new content on the site and users weren't seeing it. New images, new ads, things like that. Some users would see it, others wouldn't. It was really unpredictable. So I got called in. And I'm looking at this going, well, this is weird. Well, it's publishing pages. Let's go all through the normal stuff. Did you publish to a new major version? Did you approve it? Is it actually available to people? Once I did the troubleshooting, I found the 365 days. And I flipped. I'm like, what are you guys doing? The 365 days? Well, we don't want them calling back. I said, I know. And that's exactly what's happening. They're not calling back. And it dawned on them what they had done. They're like, oh no. You mean we can't put new ad content out? I'm like, not anything that's cached by the blob cache. So of course, the next question is always, well, what can we do? Well, this is a bell that is not easily unrung. You can instruct users, and now again, this is a public site that's used across the country. You can instruct users to go and flush their caches in their browsers. That's not going to be very effective. But if you don't do that, there's no way to force the browser to call back. You can't. You sever the connection. What we ended up doing was very painful. Again, since the matches occur by the URL request path, we had to go in and change the name of every single blob cached item in the site collection, in the master page, in the modifications. So, you know, blank.gif became blank-2.gif, that sort of thing. Every single asset, CSS, JavaScript, PDF, you name it. That was a very painful lesson. So, what I'm going to tell you here, if you don't want persistent client-side caching when the blob cache is enabled, you can explicitly set it to a value of 0. What this does is it gets you roughly a 50-50 behavior where an item will be cached locally, but when the value is 0, the browser will each time go back to the server and say, has this object changed? So you don't cut down on the number of requests back to the server, but if the object hasn't changed, the server will not send a new version down. It'll simply send that 304 that I was talking about, which says not modified, and so the browser uses its local copy. So you can cut down on bandwidth consumption, but you won't cut down on the number of requests. And in many cases, that works for people. So just be aware of this. So how does blob caching affect the farm? Well, simply put, once you turn on blob caching and the cache fills on the web front end, you dramatically reduce the amount of bandwidth that's being consumed between web front ends and SQL Server. That's because blob cache items make up the majority of the data in terms of size that's represented in a site collection. So basically, all of that stuff gets relocated to the web front end and served directly from the web front end. Now, if you use a max age other than 0, you can cut down on the number of requests that are coming in to the web front ends themselves, because depending on how long your max age is, the item will be served from the local cache without calling back to the server. So this serves to cut down the number of requests that are coming into the web front ends. So depending on how you use the blob cache, you can get 1 or 2 major offloads in terms of performance. So let's jump into page output caching. Now, page output caching piggybacks on the ASP.NET output cache. So the brutal truth here is, if any of you are developers and you've used the output cache in ASP.NET, you know a lot about how SharePoint does page output caching itself. SharePoint does add a layer on top of that to make it easier to configure and work with, but in essence, you're using ASP.NET output caching. So when we look at our page, it's easier to identify items that aren't cached than by pointing out the ones that are. So I've got red X's through things that are served through the blob cache, because those are separate HTTP requests. The item that says "Welcome back, Bob" in the middle of the page, I may go into that in a little bit, but let's just say if there's something that's personalized content, that's probably not something we want cached in the output cache. So we can customize controls. By customize, I mean write custom code for certain controls to get them to opt out of the page output cache cycle using something called post-cache substitution for a control. Like I said, I'm not going to get into depth in that in this particular talk, but I do cover that in my developer talk. So in essence, what the page output cache does is it takes the entire HTML page response and stores it in memory. So once a page has been rendered, it gets served directly out of memory. And this is tremendous in terms of performance improvement. So like I said, red X's go through the items that aren't covered by output caching. So let's talk about it a little bit. This is backed by memory. And so pages that get rendered go into memory on your web front ends that are part of the worker process. This is turned off by default. I say thankfully. I'll tell you why I say thankfully in a little bit. And the default size or allocation is none. The reason I say that is there's not a hard memory cap that's put on this. The items that are stored in the output cache are determined by what are called cache profiles. Every site collection can have 0, 1, or 2 profiles in use. You can choose not to enable the output cache, and if you enable it, you can choose to enable it for anonymous requests, authenticated requests, or both. Anonymous requests are usually pretty easy because that's the publishing scenario where everybody's the same and we want to speed things up. Authenticated requests are inherently different because we usually control what people say in an authenticated basis based on who they are. So access control lists typically come into play, and we want to configure the output cache differently. So the profiles that we use determine how many pages get put into memory, and memory use can grow or go down based on our profiles. So if we have a very generic profile that captures the bulk of the users coming in, we'll have fewer pages in memory. If we use a lot of different pieces of data and various criteria to segment our users, we'll get a large number of pages generated, and those will grow the memory consumed. So it's based on your profile. Now, since the memory can grow or shrink based on the profile, the same trick that we use with the object cache can be used for the page output cache. We have an output cache profiles node that has this use cache profile overrides. If we set that to true, then what administrators specify in this element will override anything that's set within the site collection administration settings. And this is important because more so than object caching, we have the tremendous variance in the amount of memory that gets consumed in the worker process based on output profiles. So how's this thing work anyway? So it's one of the fundamental hurdles I had to get over with the output cache was how it worked, and that's why I want to go through the page of the point of specifying how it works. The page output cache is like a big lookup table, and most caches are like this. We have a set of key value pairs, okay? Each page that is requested from SharePoint, the page request itself, so the URL, any request headers that come in from the browser, that page request gets broken down into a set of characteristics. So naturally, the page that we're looking for is typically an item that goes into this. The browser type, whether maybe we're using Safari versus IE versus Chrome, that can play into this. Any number of varying characteristics, anything you can put on an HTTP header, sometimes on a query string, all of these different factors can be considered. We select the ones we care about with the profile, and then we build a key from them. So the idea here is every user, when we select these profile characteristics, every user that has a matching request based on these characteristics is going to have the same key. The idea being that we build a key, and if everybody has the same key, we give them the same page. Now notice I said this is based on the request. One of the fundamental challenges for me, at least initially, was I thought that the page that was rendered and sent to the user somehow played into how things were cached. It has absolutely no significance in this process. It is strictly the request regardless of what gets generated. So the URL, the headers, the query string, those are the various characteristics that you can leverage to build this cache key. Now when a user makes a request for a page and the key gets built, the first thing that happens before we go through page rendering is the output cache system goes, okay, do I already have in my lookup table an instance of this key and a page associated with it? If I do, let's shortcut the entire page rendering process, pull the HTML page out of memory, and shoot it down to the user. So when someone has gone through and generated a page and had it put into the output cache, if the next user or some subsequent user comes in and generates the same key, they'll get that page out of memory and have it sent to them and bypass the entire page rendering pipeline, which if you remember early on, I had all those different events and methods that can happen for a page. You cut all of that out, which is fantastic. Now, if a page doesn't exist in memory with that key, let's say maybe nobody ever hit that page, or several minutes have elapsed and the page has expired and been ejected, then SharePoint will go through and render the page and put it into output cache memory with the key so that subsequent users can get the benefit of that. So, if Jeff goes in and renders a page and puts it into memory, and I go in and hit that web front end, and I happen to be using the same browser, requesting the same page, having the same characteristics as Jeff, as determined by that page output cache profile, then I'll get the page that was rendered for Jeff sent to me. So the trick here is really to balance profile granularity against memory consumption, because we don't want to make profiles so non-specific that people maybe with different browser versions are seeing the same HTML output if the browser happens to care about the way in which things are rendered. Or naturally, we wouldn't want to cache default.aspx and send that to somebody who has requested page1.aspx. They're fundamentally different pages, and so we don't want to send somebody page 1 if they requested default, or vice versa. So when we build our profiles, we need to include enough characteristics to slice and dice pages, browser types, query strings, and other things effectively so that we're not sending people the wrong page data. Now, if we make that too granular, we can specify tons of different profile characteristics. But every time we do that, we reduce the likelihood that a user coming through is going to generate a key that matches something that's already in memory. And so we slice and dice it too many ways. We have too many pages in memory. We chew up too much memory, and we can basically cause our worker process to recycle over and over again. Not a good situation. Now, the whole process of setting up profiles, we don't have time to go through that right now, so I want to skip it. But there are techniques and there are articles out there on how to do this. Eventually, you will get to the point where you can enable the output cache. And this is where I tell you, stop. Don't check that button, or don't check that checkbox just yet. You really, really need to do concurrent user testing, multi-user testing, with your cache profile settings before you turn it on for production use. This takes us to the next painful part of my admission of guilt in other people's environments. We were about to go live with this really big site redo, and we were online testing late one night. Multiple people were in hitting. The site was looking great. Things were performing. So a number of people go in and hit the site after we just started up. Catherine goes in. She gets a page that says, "Welcome back, Catherine." And then Nate goes in. He gets a page that says, "Welcome back, Nate." And then Andy goes in and he gets a page that says, "Welcome back, Catherine." And then I go in and get a page that says, "Welcome back, Nate." And so Nate goes in and gets a page that says, "Welcome back, Catherine." And everybody starts freaking out, especially me, the admin, who had turned all this stuff on. Ultimately, we had to turn it off. But the problem was my cache profiles weren't granular enough to understand different users who were coming in. And so based on which web front end you hit, everybody looked like they had the same key being generated, and so it kept serving the same 2 pages out of the web front end memory. So ultimately what I had to do was create cache-aware controls to put on the page. If it were something else, like based on a query string, I might modify my profile, my cache profile, to look at that query string parameter. So this is where I say you need to balance profile granularity against memory consumption. Because if profiles are not granular enough, you may not distinguish between users the way you need to, or you may not distinguish between 2 page requests in the way that you should. And that's why you need to do concurrent multi-user testing. Because in the single user scenario, you may never see these things happen. All right. Now, where do we get benefits from this in the pipeline? This is the big kahuna. This has the potential, and in my developer talk, I talk about this where I ran some numbers. I saw a 5 to 6-fold improvement with the page I was using. 5 to 6-fold improvement over page generation without output caching enabled. So that is no small, that's not 10%, that's not 20%, that's 500 to 600% throughput, because we bypass that entire rendering cycle. So something to keep in mind. It is great when it comes to improvements, but it also is the trickiest form of caching to try and get right. All right, so since we're running short on time, let's zip through a couple things. The Office Web Apps Cache. This is specific to SharePoint 2010. Do we have anybody on SharePoint 2010 in the audience? Show of hands. Jeff, what do you see?
1 hand. 2 hands.
2 hands. Okay, so we will go through this. So with 2013, we now actually have WAC servers that are their own farm, web accessibility companions that are their own farm. But in SharePoint 2010, if we use the Office Web Apps Cache because we're using Word and Excel and PowerPoint in the browser, this is what's in play. The pages that we create and that use Word, Excel, PowerPoint, what we're in essence doing is generating web pages that look like those applications. Now, an Office Web Apps Cache houses image, the XAML that's generated so that documents that we're looking at and editing or viewing through the browser can look like their counterparts in the bona fide Word, Excel, and PowerPoint applications. So the way that this cache is implemented, if you've ever been in central administration, some of you might have wondered, hey, what's this /sites/office viewing service cache? Well, that is the Office Web Apps Cache for that web application. It's another standard site collection. It's literally a team site collection. You can browse to it and go in, and you'll find a document library. And if you look in that document library, you'll find a bunch of different XAML documents. Each web application of these in a 2010 farm gets one of these site collections, and that's managed by a timer job that runs in the background. With standard quotas, this can grow to consume 100 gigabytes by default, and we have a 30-day content expiration period by default. So what can we do here? Well, by itself, it generally runs pretty well. But if you want to tune up or make changes to the Office Web Apps Cache in 2010, you'll want to get friendly with the Set Office SP Web Apps Cache PowerShell commandlet. That is how we can officially make changes to the Office Web Apps Cache. What I tell people right off the bat is you probably, within each web application, want to relocate this cache to its own site collection in a dedicated content database. The reason I say this is if you're doing backups, you don't want to back this data up. It's temporary data. And based on the number of web applications you have, that number times 100 gigabytes is how much backup space you can be wasting by backing this up. So get it into its own dedicated content database and omit that database from your backup cycle. Now, if you can increase or decrease both cache size and expiration for documents that are being housed based on how frequently content turns over. If it doesn't turn over very often, you're typically in more of a read-heavy scenario. You can extend the duration and the size of the cache to be more effective. But if things turn over very frequently, you can actually reduce that number. So it's totally up to you. Now, I say I've got some scripting help for you on this. There's a link in the resources that I need to update. I'm going to put this out on my blog in the next day or two, along with these slides. But I wrote something back when I worked for Idera. I put together a whole write-up, and what we had was called a SharePoint Smarts newsletter, where I include some PowerShell scripts that you can use to tune these things. I'll go ahead and republish that on my own blog here in the next day or two, so keep your eyes open. Now, finally, the distributed cache service. What I like to tell people is the distributed cache service is to SharePoint 2013 what the user profile service was to SharePoint 2010. It is a pain in the neck for most admins. And to be fair, it's not the distributed cache service itself, it's the underlying app fabric service. Now, this is SharePoint 2013 and beyond only. So if you're 2010, this doesn't apply to you. But for 2013 and beyond, this is in play and it's very important. This is memory-based caching where several types of data and objects get stored. Now, the distributed cache is distributed because, as its name applies, if we have more than one host in the SharePoint farm, by default, when we're setting up SharePoint, each host is going to be set up as a distributed cache cluster member. And so the cache, the total cache, is distributed across each member in the farm. So in the case of two hosts where we have 8 gigabytes that we've allocated to the cache, the total cache cluster for that farm is going to be 16 gigabytes. Now, the types of objects that get stored, now that we're in the days of claims-based authentication very solidly, authentication tokens get stored there because the orchestration of contacting an STS and setting up tokens, even if they're farm-based tokens for on-prem or you're doing OAuth, those are very expensive and time-consuming to generate, relatively speaking. So we want to cache those as long as we can. If you're used to social news feeds live exclusively in the distributed cache. So if you shut a cache cluster down and you don't do it gracefully, you may wipe out somebody's news feed until it gets repopulated. And there are other things that get put in that cache too. So when you first set up SharePoint 2013, you're running in what's called co-located mode, which means the cache gets added to every host, regardless of what that host is doing. Maybe the host is an indexer, maybe it's a web front end. But ideally, in better performing environments, you want to get to using cache hosts in dedicated mode. And this is much easier with SharePoint 2016 with min role adjustments. We can set up servers strictly as cache members, and we can get other services taken off of them. And in co-located mode, although SharePoint has been accused of being moody before, in co-located mode, 10% of your server's total memory is going to be used as distributed cache memory. So keep that in mind. That's how it gets set up if you don't do anything else. So is there any guidance? Well, Microsoft will tell you do not run the following services on the distributed cache host. SQL Server, Project Server, Excel Services, Search. These are all resource-intensive, CPU-intensive services. They conflict with great responsivity in the distributed cache itself. So we want to get heavy-duty processing away from our cache clusters. We also can look at the health rules. If there's something wrong with the distributed cache, we might see something in the health rules that gives us an idea as to what's going on. And like Microsoft says, if possible, run App Fabric on its own server. So put your distributed cache hosts somewhere other than your other farm operations. Now, is there anything else you can do or tweak? Yes. This warning used to be up on TechNet. I love this. The distributed cache service can end up in a non-functioning or unrecoverable state if you do not follow the procedures that are listed in this article. In extreme scenarios, you might have to rebuild the server farm. that scare you? That scared the death out of me. Well, scared me to death, rather. The first time I read it, I'm like, don't touch, don't touch. So the warning here is tread carefully. This was back in the days when Microsoft said, don't patch App Fabric separate from SharePoint. They've changed that guidance. Lots of things have turned around. That said, here are my suggestions. If you need to stop the cache, use the dash graceful switch. This will shunt data that's in the distributed cache host to other cluster members so you don't lose data, and then it shuts the local cache down. If you just shut the cache down, if you kill the service, you lose stuff in memory. Get an App Fabric patch, not AM App Fabric cache, but AN, that should be an N. The newest is CU6, Cumulative Update 6. Honestly, I would go with Cumulative Update 5. 6 is still finicky. They reintroduced something. I don't know if it's a regression or what, but Cumulative Update 5 was pretty rock solid. And after you patch the service, one of the things that I believe came with Cumulative Update 3 was this background GC setting. GC is garbage collection. The distributed cache has to clean itself up now and again. But previous versions of the App Fabric cache ran garbage collection on a primary thread and slowed it down. The background GC setting allows you to run garbage collection in the background for much greater throughput and concurrency success. So, use that setting. It is called out in the TechNet article where you would get the cumulative update. Now, this is an important one for you folks on virtual infrastructure, which is most of us these days. If you're running the distributed cache on a virtual machine, do not use dynamic memory. This is the idea that the host gives and takes away memory from VMs based on memory load. This messes with App Fabric, and you can get into a very weird sort of seesaw scenario where memory is allocated, the cache takes it, the server takes some of it away, the cache rebounds. You can get into very weird operations. So fix the memory that's used by your cache hosts. Okay, so I'm just at about time. I'm going to zip through a couple of these. I only have like 5 or 6, but we'll go through them pretty quickly. So let's say the cache is reduced significantly below 100 megabytes. You guys remember what happens there? We'll make this rhetorical so we don't slow things down. The potential result, this is where you become memory constrained. You end up with resource contention and ejections. That leads to cache compactions, and under heavy load, you can get some thrashing, and SharePoint's ability to serve pages falls through the floor. And in my case, completely tip the servers over. And so, in general, cats and dogs living together, mass hysteria, all that bad stuff. So what to watch? The publishing cache hit ratio counter has been around forever. Here's the dirty secret about the publishing cache hit ratio counter. It only resets when you reboot the server. So if you've been up and operational for 30 days and you've got a 99% hit ratio, let's say on day 31 you get no cache hits. Guess what? Your ratio is going to go from 99 to about 96%. It still looks pretty good because you're only losing one day out of 31 or 32. So don't use that. I mean, it's a good number as a baseline. The number you want to watch is total number of cache compactions. If that goes above 0, you need to watch it closely because what we're seeing here is cache compaction behavior. The rule of thumb, and I've got a blog post on this too, the rule of thumb is if you get to 6 cache compactions per hour or greater, your server's object cache is under heavy stress and you need to allocate more memory. So keep an eye on that performance counter, and like I said, if you're interested in more, I've got a blog post on that. So let's say in the page output caching scenario, user A requests a page, user B requests the same page, but user B sees information tied to user A. I talked about this in the Catherine Nate scenario. The situation here is the page output cache profile isn't granular enough to distinguish user A from user B. So what you can do in terms of these are in order of increasing invasiveness. You can refine the cache profiles in use to add additional attributes, for instance, to try and generate slightly longer different keys to differentiate those users. You can actually set cache exclusions either by subsite or page layout type. So the idea here being maybe everybody sees the same home page for a site, but you've got a subsite where you're showing personalized content to users. We'll just exclude that subsite from caching by setting an exclusion through the controls in Site Collection Administration and cache the home page. That way you get the benefit of everybody seeing the same version of the home page. You render it once, but then people get their own non-cached versions of their personalized pages. Now, if you're building custom controls in an on-premises scenario, you can use something called post-cache substitution, also known as donut caching. Probably another reason I love it so much. Anybody who knows me knows I love donuts. You can implement that in your code, and then finally, there's what I call the nuclear option. You can implement the iVaryByCustom handler interface in a piece of code and tie yourself into the page processing pipeline, typically through an HTTP module. And you have the ability to directly influence the key that is built for each page that gets requested. This is very invasive, very tough to do. I do cover it in my other presentation. And if you've gone this far, chances are there are better options up the chain. But it is an option if you need to use it. So if memory consumption, again, on page output caching, if memory consumption of your ASP.NET Worker process grows significantly over time, performance may deteriorate. Reason for this, you may have made your cache profile too granular, and so too many pages are going into memory. So adjust your cache profiles to reduce the page load. That is, maybe drop some attributes or criteria out of the profiles. You can selectively disable caching for highly varying subsites or page layout types. Finally, if you're really a gearhead, you can get in and tinker with the private bytes limit on the ASP.NET Worker process. And again, if you have to go that far, chances are you might be better served by one of the two previous techniques or even adding more memory to the server. It depends on what you're trying to do. Blob caching. This is primarily for the 2007 scenario. Path property is set correctly, location set correctly, blob caching is enabled, but images stored in the site collection aren't being cached. Like I said, this used to show up a little more often. If the blob cache, if you're trying to cache items that aren't in a list or library, you need to get them into a list or library. That's an easy fix. So either create a custom list for them, move them into the site collection images library, whatever, but get them out of the virtual file system when they aren't associated with a list or library. This one's one of my favorites. The image is changed on the SharePoint site. Some client browsers show the new image while others show the old image. As in 365 days show the old image. Well, the high age, somebody might have set a very high max age attribute. And if that's in use, really, you can instruct users to clear their browser cache and revisit the site. If you haven't served up the assets yet, you can set it to 0 to disable persistent client-side caching, but recognize that this behavior is by default or by design. So these are resources. Like I said, you'll be able to pull these down. My information, you can ping me on Twitter. I've seen a couple posts up here. You're welcome, Matthew Carter. I'm glad you're enjoying the presentation. SharePointInterface.com is me. Feel free to hit my blog. I've got tons of caching posts, particularly on the blob cache, but other things as well. These slides will be up there in the resources section sometime this evening. And feel free to ping me if you have additional questions. But for now, I've chewed up a little more of your time than I should have. Does anybody have anything they want to ask?
Come on up.
Come on down.
While they're walking up here, I won't raffle these. Hey, these enlarged Office 365 dev shirts. Anybody want one?
Hi, Sean.
Hi.
I have a question about your blob storage. When you went to 365 days, what happens if you rolled it back to the 86,000 seconds? How come that wouldn't work?
Well,
How come the server wouldn't go through and just...
It does work. So for items so think about this from the client side perspective. When I request an item that's served by the blob cache, that cacheability header comes down. And so for new items that I don't have in my cache, they'll get the new value, the 86,400. The problem is with the items that are already cached locally. They know 365 days, and for 365 days, no request is going to be made back to the server to get that new value. That's the problem. So when something's already in the cache and it has that cacheability header that's set for 365 days, unless you clear the browser cache, for 365 full days, the browser will not re-request the new item. It will be served locally. That's why the new header won't make a difference until the item is re-requested. When 365 days later, when the browser re-requests it, then it'll come down with 86,400. But you've got to wait out that 365 days. Does that make sense?
Yep.
Okay.
Okay, thank you.
You're welcome.
Just a question when we go editing those all those web config files. If you have multiple web front ends, what happens if they're not perfectly the same? And I recall, and what happens if you hit one web front end once and then next web front on another on the next hit? How does that all work? How does it not blow up?
Well, it won't blow up. It'll just, so the blob cache, of course, is local to each server, just as the web config is local to each server. When you're editing the web config, it's going to force an app domain rebuild, so your worker process won't recycle per se, but on that local server, you'll spin up a new app domain, and it'll drain stop the other one, so the worker process effectively gets the newly loaded settings. That's all fine from a single server perspective, but you're asking, of course, about multiple. So if you've got a load balancer like an F5 out in front or a big IP, if you've got NLB, Windows load balancing in effect, and people are bouncing between servers, then really the headers that come down for a blob cache item are going to depend on where that particular request was serviced from. These aren't mutually exclusive. I mean, if you end up making a change to one server and you don't touch the other so that the max ages are different, or it's enabled on one server but not on the other, really that doesn't affect from a consistency standpoint, from a user requesting the page. It just means that some items might be cached, others might not. They might have different headers and different lengths of time being cached, but it doesn't somehow destroy the page rendering process. You're just going to get, if you don't have affinity set, and now Microsoft recommends, as a rule of thumb, since, starting with SharePoint 2007, Microsoft has never come out, I think, and directly said it, but they've always advised setting some form of affinity on your switches or your load balancer, so that whether it's IP-based or some other source-based affinity, you peg people to one web front end for greatest consistency. And this was most often in play anytime people were using InfoPath, because if they got posted back, if they got a form from one server and posted to another, the MAC check would fail on that other server oftentimes if people hadn't taken care of their machine keys, and it would blow up. But even without that, Microsoft recommends you peg people to a single web front end. If you don't do that, it's still okay if the settings are different. It just means some things might be cached, some might not. Now, when they come back, if they go to a server where, caching is enabled, and they don't have those assets cached on the browser, well, they'll get pulled down and cached. By the same token, if they go and visit where there's no caching, well, the items that are still stored locally in the browser, we're not going to generate HTTP requests for those items if the max age attribute value hasn't elapsed in terms of time. So those still get served locally. If they do call back to the server and it hasn't changed, they'll get a 304. So you may have different values and the behavior in the servers may be different, but ultimately the page will still get rendered and all the assets will get pulled down.
And last one.
Yeah, so Sean, I had a question. So what would happen if, I know you mentioned something about saying that we can still configure blob cache and stuff per site collection, but I mean, can you go a bit in detail of per zone? Yes. So I have a site collection, like a host name site collection under my web app, and I want to enable the blob cache only on that particular site collection and not the other site collections.
Okay, so
how
only,
can
only that site collection?
Yes.
You'll end up getting into, so in the web config, in the path regular expression, you're going to need to craft a regular expression that considers path information that's based on that site collection URL. So right now, by default, if you don't change it, it's only going to consider the extension of the file types you're requesting. You're going to need to modify that. So The simple answer is you'll have to craft a regular expression. There's one post on my blog where I think I did specifically that. I didn't do the entire URL, but I did a portion of the path so that a particular document library was excluded from the blob cache. You can go ahead and use that as an example, but you'll want to make friends or get with somebody who knows regular expressions or get really good. There are plenty of online resources for that. You can also, there are apps that you can download that will allow you to test regular expressions against different strings to see where the matching will occur. Take a look for that online and find that post on my site. I think it was the one I posted that said, do you know what will happen when you enable the SharePoint blob cache? But if you get in there and look and you can't find any of these resources, go ahead and shoot me an email or post something on my blog, and I'll see what I can do to help you out.
Sure. Thank you so much, Sean.
Sure thing.
Actually, just one more question.
Sure.
Hi, Sean. Thanks.
Hi.
Just one quick question, and it's just a general question. Are there any special considerations for like publishing like Power BI dashboards?
Power BI dashboards. I'll start by saying I don't know a whole lot about Power BI. Now, somebody who knows Power BI, is that actually rendered in the SharePoint pipeline, or does that end up coming in as like a provider-hosted application that's put into an iframe? Does anybody know?
That'd be a good question for Jason or David. They wrote the book on it.
Are they there?
No.
So here's, and this is, again, I don't know Power BI to save my life. Jason Himmelstein I know would be a good guy to ask, and that's one of the people referenced. What I suspect is current versions of SharePoint, since that's handled as a separate application, I suspect Power BI dashboards are rendered under the provider-hosted add-in model. And what that does is, in essence, it creates an iframe which puts a window on your page, and another server is filling in that input, filling in that region. That region is not going to be subject to any of the caching mechanisms that we're talking about because it's literally isolated from the other areas on the page. So SharePoint will cache the HTML around that iframe. It may cache various aspects of the data that are generated to go into that page, but the iframe itself is hands-off. And so any type of caching that's occurring for that is going to be off on your Power BI service application or server. That's my gut feel. Validate that with somebody who does Power BI. If they're not sure how it interfaces with SharePoint, let me know who you talk to, because chances are I may know them as well. And I'd be happy to have a conversation with them so that the two of us could figure out whether or not that would be cached and get back to you.
Well, thank you so much, Sean, for being with us tonight and coming all the way from Cincinnati to Boston here. So thank you. Much appreciated.
The power of the interwebs.
Definitely. Well, thank you again, and round of applause for...
Thanks for having me. I had a real good time. I enjoyed talking to you guys, and like I said, feel free to follow up with me if you come up with additional questions or you're off researching something and trying to figure out how it works. I've spent tons of time under the hood messing with these systems, and so I'm happy to share whatever I've learned.
All right, well, we'll have to have you back again soon, since this worked out so well.
Awesome, yeah. Let's do it again.
If you would have us.
Absolutely. I'm happy to do this. I'm sitting in my office. This is where I'd be anyway.
Awesome. Well, hey, thanks again, Sean. And Em says hi. She's not here tonight. But she
tell her
says
I said hi, too.
I will. All right. Thanks again, Sean.
You bet. Take care, everyone.